I welcome to my YouTube channel. God's willing, today shall be taking us on Iupac nomenclature. So if you follow our previous classes, I've already defined organic chemistry, terms used in organic chemistry, and I told us the meaning of Iupac nomenclature. So today we want to enter the nomenclature in details. That is how to name an organic compound. So please, like I said, if you have not subscribed yet to this channel, go to the subscription box and do that. Click on the subscription box, please, so that we can keep updating you on these Jamb past questions or Jamb questions under what? Chemistry. So as you can see this structure here, Jamb asks for the name of this compound. So the issue we have about students is that they always find it very difficult to name an organic compound. But believe me that organic chemistry is the most simplest aspect of chemistry, most especially when it has to do with nomenclature, that is naming of organic compound. So today we want to see how we can name an organic what? An organic compound. How do you name an organic compound? That's it. So following the rules I gave us in the previous class, we are going to follow the rules one after the other to see how we can name this compound. That's very good. So the first thing here, I told us that if you see a structure, then you have to look at the structure very critically. You look at it very critically, and you try to consider every carbon if there is what we call substituents at the carbon atom. Are we following? So now, that will also enables you to know where to number the hydrocarbon chain. Because if you number it wrongly, you will miss the question. So you have to be very careful. As simple as this structure is, you also have to be very, very, very careful for you to name it. Okay, let's try to name it. Let's try to name this compound. Like, you first of all look at here. Where do we have substituents? So look, let's start from here. Do we have substituents here? We don't have substituents. Now you can ask, what are substituents? We say substituents are secondary structures that are attached or linked to the main structure. They are secondary structures that are attached or linked to the main structure. So now, if I'm looking at this structure, is there anything bonded to this structure aside hydrogen atom? Yes. What is that? Can you see chlorine here? And I told you that here we don't call it chlorine, we call it what? Chloro. So Cl is an example of a substituent. When you have Br, Br also is an example of a substituent. Then when you have CH3, it's an example of a substituent. When you can also have I, you can also have F, you can also have this acting as a substituent. So you call this one chloro, you call this one bromo, you call this one methyl, or you can call it methyl. Then we can call this iodo. This is fluoro, and this is what? Hydroxyl. This is hydroxyl. So if any of this is attached to the compound, how do you name the compound? So as we can see here, that at this very carbon atom now, you have this Cl, which is called what? Chloro. So can we try to name this organic compound? Let's try. So we say if you want to name an organic compound now, after knowing if you have substituents on the structure or not, then you must what? The first rule says we should choose the longest carbon chain, or that we should choose the longest continuous carbon chain. So you have to look which of the carbon chain is long or is longer. So now, if I want to do that now, look at it here. I can come here. Is there any carbon chain? Or let's go like this. 1, 2, 3. This is a carbon chain. 1, 2, 3. Can you see? 1, 2, 3. Then this is another carbon chain. 1, 2, 3, 4. Or 1, 2, 3, 4. So going like this is longer than going like this. Do you get that? So the first rule says the word, we should choose the word longest continuous word carbon chain. So if I want to choose this longest chain, I will go like this. Do you understand? I will go straight. Either I go from my left to right or right to left. Then we'll see how to also number it. So my longest carbon chain is from here. It's from this place to this place. So after choosing the longest continuous carbon chain, the rule number 2 is saying what? We should number the longest continuous what? Carbon chain. Number what? The longest continuous what? Carbon chain. So if I want to number it now, I can say 1 here, 2 here, 3 here, 4. So can you see that the longest chain here is how many? Is 4 carbon atom. So that's good. So if you choose your longest chain and you number it, you are there. So now the third rule says that what? If there are substituents in the structure, that is, if there are secondary structure attached to the main structure, we should number in such a way that the substituents will have what? Less what? Number. You should number in such a way that the substituents will have less number. Now, you might ask, why didn't we number from here? What didn't we number from here? 1, 2, 3, 4. Okay, let's take the both sides now. Assuming we number from here, from left to right, and we number from right to left, let's try to see which one is correct. Because the next rule said, after you choose the longest continuous carbon chain, then you should number your longest continuous carbon chain. And the next one said that in numbering the longest continuous carbon chain, you should number in such a way that your substituents will have what? Less number. Number in such a way that your substituents will have less number. So as you can see on these structures, let's try to bring out our substituents so that everything will be smooth. Let us what? Brings out our what? Substituents. So if I want to go from this side to here, at carbon number 1 is a normal bonding. I don't have any what? Substituents. At carbon number 2, I have what? Chloro. Chloro. So you name it as 2 chloro. You get that? You name it as what? 2 chloro. So that is a carbon number 2. I have chloro. This is carbon number 1. This is carbon number 2. I have what? 2 chloro. Let me clean this so that you understand better. Okay, can you see? So at carbon number 2, I have what? 2. I have chloro there. So you call it 2 chloro. Then as the carbon number 2, I have a methyl group. CH3 is called what? A methyl group or methyl. So I have CH3. So I call this one methyl. I call this one what? Methyl. CH3 is called methyl. At carbon number 3, there's no any bonding. Is a normal bonding, and at carbon number 4 also is a normal bonding. So that's all. So if I want to name this compound now, can you see? Then okay, that's all. If I want to name this one now, I can say what? 2 chloro, 3 methyl what? Sorry, 2 chloro, 2 methyl, 2 methyl, 2 chloro, 2 methyl what? Butane, butane, butane. 2 chloro, 2 methyl what? Butane. Now, if you number from here to this side, if you number from right to left, now let's assume we number from here. You have 1, 2, 3, and 4. If you number from here, you have 3 chloro, 3 chloro, and what? 3 methyl. So if you call it 3 chloro, 3 methyl butane, is wrong. You did not follow the what? Iupac rules and regulation. So if you name it like this, it's wrong. So the right way to name this compound is to call it what? Is to call it 2 chloro, 2 chloro, 2 chloro, then 2 methyl, 1, 2, 3, 4, butane. Butane. So that's the name. So this is a Jamb question. So this is 2 chloro, 2 methyl what? Butane. Very, very, very simple. So let me give us another structure again. Another structure. Okay, what you need to know here, why do we start from chloro, not methyl? What you need to understand is that if you have two or more different substituents in a structure, you will name the structure in alphabetical order. So looking at this, chloro comes before methyl. So that's why we are saying what? 2 chloro, 2 methyl, instead of 2 methyl, 2 chloro. So C comes before M. Do you understand? In alphabetical order, C comes before what? M. So you have to start from chloro before you come to methyl. That's why we are having it like this. So look at this structure again.
Iupac nomenclature.
So I can have this structure. I can have this structure. I can have a structure like this. So what do you call this one? What do you call this one? We say the first thing you need to do is what? To choose your longest carbon chain, or your longest what? Continuous carbon chain. Which longest chain is longer? That's what we're asking. So now you can come like this if you want to go. And secondly, once you see the structure, try to identify your substituent. All right? Try to identify your substituent. So if I want to identify my substituent first, in this carbon atom, there is no any substituent. This is a normal bonding. Hydrogen and carbon bonding is a normal natural bonding. So there's no any substituent attached to this. If you come to this one again, this carbon here, there's no any word substituent attached to it. This is a normal word, hydrogen and carbon word bonding. So it's a normal one. There's no any substituent attached to it. So remember what we say about substituent. We say they are what? Secondary structure that are attached to the main word structure. So if I come to this very carbon here, you can see that I have a substituent. And the name of the substituent is called what? Methyl. This is what? 3-methyl. At carbon number 3, I have what? I have methyl. Then at this carbon also, I have bromo. And at this carbon, I have also bromo, and I have chloro. But if any bonding between hydrogen and carbon is a normal one. So now, after identifying your substituent, the next thing now, you choose your longest chain. So if you look at this structure critically, you see when you move from this side, 1, 2, 3, 4, 5, or you move like this, 1, 2, 3, 4, 5. Can you see? Then if you want to move in this direction, 1, 2, 3, 4, or in this direction, 1, 2, 3, 4, or 1, 2, 3, 4, or 1, 2, 3, 4. Can you see that either going like this or like this is the longest? So how do we choose this? So if I go to from left to right is my longest, or from right to left is my longest. So it's either I go by this direction or I go by this. That's good. Now, if you choose your longest chain, the next thing is what? Is to number your longest chain. So if I want to number here, can you see 1, 2, 3, 4, and what? 5. And remember, in the numbering, we said that what? If you are numbering, you should number in such a way that your substituents will have what? Less number. So you are not just numbering anyhow. If you look at the previous structure, we number from this side to this side. Reason is because more of the substituents are on this side, and we number in such a way that they should have what? Less number. So if you look at this structure again, you can see that most of the substituents are here. So we have to number in such a way that the substituents will have what? Less number. So if you number from here, you have 1, 2, 3, 4, and 5. So I want to number this my substituents. At carbon number 1, I have bromo, and at carbon number 1, I have what? Chloro. So it will be 1 bromo, 1 bromo, then it will be 1 what? 1 chloro. Then at carbon number 2, I still have another bromo. So I will call it what? 2 what? 2-bromo. So that's good. At carbon number 4, I don't have any substituent, and at carbon number 5, I don't have any substituent. So if you have the other rule says that after numbering in such a way that your substituent will have less number, if I have 2 or more similar substituents, like if I have 2 similar substituents, I will join them together and name them as di. If the substituents are similar and they are 3, I will call them what? Tri. If they are 4, I will call them what? Tetra, etc. So if I have 2 or more similar substituents, that's another rule. You number, please. 1 say choose the longest chain, number the longest continuous carbon chain. 3 say number in such a way that the substituent should have less number. Now, number 4 rules or 5 rules is saying that what? If I have 2 or more similar substituents in a structure, I should number it as di, tri, or tetra. So, can you see that we have 2 similar substituents, that is 1-bromo and 2-bromo. 1-bromo and 2-bromo. So, I cannot name this compound 1-bromo, 2-bromo, 1-chloro, 3-methyl pentane. If you number it like that, or you name it like that, is wrong. Since the 2 substituents, 1-bromo and 2-bromo, are 2 similar substituents, then you will name it as di. And how do you do that? It will now be 1, 2. It will now be what? It will now be 1, 2. It will now be 1, 2. It will now be 1, 2 dibromo slash 1 chloro, 1 chloro, then slash 3 methyl 1, 2, 3, 4, 5 pentane. What? Pentane. So can you see how simple this thing is? It's just for you to follow the rules. And you know, if you are naming now, you will name it in alphabetical order. So here you cannot just name the compound anyhow. You know, in alphabetical order, B comes before C. So you will mention bromo before chloro. That's why we started with 1, 2 dibromo. What we are saying, 1, 2, a carbon number 1 and a carbon number 2, you have what? Bromo. A carbon number 1 and a carbon number 2, you have bromo. That is what we mean by 1, 2 dibromo. So, and the bromo are 2, so you call it dry. Look at the bromo here. Look at the bromo here. Carbon number 1 and carbon number 2. That's why it calls 1, 2 what? Dibromo. That is 2 bromo. At carbon number 1 also, we have chloro. So can you see? You call it what? 1 chloro. Then at carbon number 3, can you see? 3 here. You have a methyl group. 3 methyl. Then the name of this hydrocarbon chain, 1, 2, 3, 4, 5, is called what? Pentane. That's also this. This is the name of this structure. So keep following and asking questions. Please, if you have a question, you can just go to the comment side or box and ask your question. So let me give you a work. Let me give you a classwork or a homework. If you do, you just drop the answer on that comment box. So now if you have a structure like this, what is the name? So please, can you just do this and drop the answer at the comment section? What is the name of this structure? So just follow the rules. So please, if you have not followed the class from beginning, go from the definition of organic chemistry. Now you might ask, some persons might ask, what do you call this methyl? Why do we call this methyl? Let me just say something here. The reason why we call this one methyl, we say this is what we call alkane. Alkanes and alkyls. We say that alkynes are obtained from alkanes when the alkane lost a proton or hydrogen atom. So you can go back to our last classes and follow, check, and ask your questions. So please, this one should be solved and be given. The answer should be submitted at the comment section. I wanted to teach, but